Alright students, in this video we are going to learn about how do you simplify trigonometric expression by using algebraic techniques. Okay, so let's say if we have cosecant theta secant theta minus cot theta. Okay, we need to simplify this expression. There are some strategies that you can apply to simplify this trigonometric expression, but like I will explain you one by one while I will solve questions. First thing is, we will use trigonometric identities to simplify the given expression right here. Okay, first of all, cosecant theta. Whenever the expression is given, you need to change into sine and cos terms, okay, because sine and cos terms are the simplest one. So look, cosecant theta, we know that identity is cosecant theta is equals to 1 over sine theta. Okay, I will use this identity. We know that secant theta is equals to 1 over cos theta. I will use this identity here, and this expression will become 1 over sine theta times 1 over cos theta minus, and cot theta is equals to I guess cos over sine. Yes, again it's another identity. Cos theta equals to cos over sine, sorry, it's cot theta. Okay, I will use this identity here. It's going to be cos theta over sine theta. Okay, now what do we do next? Look, these two are two different, they are two different fractions. And how do you simplify two different expressions, two different fractions? By making denominator same. So here you, in the first one, you have sine theta cos theta in denominator, correct? Now we are going to use multiply the second term, this one, with cos theta to make, and also divide to make the denominator same. Now we are going to have 1 over sine theta cos theta minus cos squared theta, okay, over sine theta cos theta. Clear? Now denominators are same. Once you have same denominator, you will combine them. They are going to be sine theta cos theta, and you are going to have 1 minus cos squared theta. Okay, so look, whenever you have squared form on something, most likely you are going to use Pythagorean identity. Look, we know that sine squared theta plus cos squared theta is equals to 1, correct? And if I will rearrange this identity, it's going to be sine squared theta is equals to 1 minus cos squared theta. Now this value, I'm going to use it here, and it's going to be sine squared theta over sine theta cos theta. Clear? Now this sine theta will cancel out with this squared, and you will left with sine theta over cos theta. And we know that sine theta over cos theta is equals to tan theta. This is the most simplified form of this expression. So look, what is this? This is about, if you have a trigonometric expression, you will use algebraic identities to simplify our algebraic techniques to simplify our trigonometric expression. Alright, so now we have another example. Sin x cos x over 1 minus sin x minus 1 plus sin x over cos x. Again, same objectives are same. We need to simplify this trigonometric expression by using algebraic techniques or by using trigonometric identities. Okay, now look here, you cannot use the strategy that I explained you before, that if you have written something you will change into sine and cos form. Look here, this is already simplified, right? Now you can use the second strategy that I explained you while I was explaining your first question. What is that? That one is when you have two expressions, or sorry, two fractions, you will combine the denominators. You will make denominator same. So here, to make denominator same, I will multiply this denominator with this one, and I will multiply this denominator with this expression. Okay, now I'm going to rewrite for you guys, and it's going to be sine x cos x over 1 minus sine x. I will multiply this expression with cos x and also divide, because we don't want to break any math rule. You have to multiply and divide. Minus 1 plus sine x over cos x, this is expression, and you are going to multiply with 1 minus sine x over 1 minus sine x. Clear? Now let's combine the denominator. They are going to be cos x times sine x cos x over cos x. It's better to make in parentheses because there are two expressions. Minus 1 plus sine x 1 minus sine x, it's going to be 1 squared minus sine squared x over, I will explain you why is it going to be 1 minus sine squared x and 1 plus cos squared x. Look, sorry, not this one. This is not squared, this is only sine x. Look, we learned, you guys must have learned a formula which is a squared minus b squared is equals to a plus b, a minus b. This formula is really important. If you compare this formula with this expression on the top, you can check that this is a minus b and this is a plus b. So you are going from this form to this one. So a squared means 1 squared and minus sine squared x. Okay, this is what you do. Now you can see that the fraction in these two fractions, denominators are same. We will combine the numerator, but before you combine the numerator, I'm going to write it down like this: sine x cos squared x, and here we have minus 1 because 1 squared is 1, minus sine squared x over cos x 1 minus sine x. Okay, now let's see what do you have. Again, as I told you, whenever you have squared on sine or cos or any value, most probably you are going to use Pythagorean identity. Now again, look at that one: sine squared x plus cos squared x equals to 1, and we know that cos squared x is equals to 1 minus sine squared x. This value of 1 minus sine squared x I am going to use over here, and it's going to be sine x cos squared x minus cos squared x okay, and down part I am going to multiply, and it's going to be cos x minus cos x sin x. Clear? On the top part you can take cos x squared as a cos squared as a common factor, and it's going to be sin x minus 1. Okay, sin x minus 1. I am going to keep it this one as no, it's fine, just keep it like this. Okay, over cos x. Here in denominator I will take negative cos x as a common factor. When you will take negative cos x as a common factor, then the expression will change into sin x minus 1. Okay, now what do you do? Sin x minus 1, sin x minus 1, they will cancel out each other. You will left with cos squared x over negative cos x. Cos x cancel with squared, you will left with negative cos x. I hope you guys understand this one, and if you have any question then just comment below. I will just explain you again that part.